Hello and welcome to Ricardo's Future Mobility channel. We are in the midst of discussing a variety of future mobility topics. Today, we're going to talk about autonomous technology and the sensor suite. Which sensors form the autonomous system? What is the cost implication today and how it might evolve in the future? My name is Anish Padalkar. I am with Ricardo Strategic Consulting in the US. I'm joined by a couple of my colleagues, Nikhil Nayak, who is also a colleague of mine in the US, and David Abdul Masi, who is with RSC in the UK. Hello, gentlemen. Welcome.
Hello, Anish. Hello, Anish. Hey, David.
So, when we talk about autonomous technology, broadly, we're talking about three main things. The first one is perception, or the sensory elements that tries to understand the surroundings. The second is planning, or the computer brain, which is trying to map the human brain in terms of decision making. And the third is control, where the computer fundamentally commands the vehicle to do certain things like a human driver would. In this discussion, we're mainly going to focus on the perception bit, and we talk about specific sensory elements such as LiDAR, and there's a debate in the industry whether LiDARs are truly necessary. We'll talk about some of the benefits of one sensor versus the others being radars, short range and long range, and cameras. So we'll kind of outline how these various sensory elements interact with one another, what are the benefits of each. Then we'll talk a bit about the cost structure and some of the evolution. So let me pass on to Nikhil. Nikhil, do you want to talk briefly about these sensory elements and the benefits one versus the other?
Sure. So let's when we talk about autonomous driving systems, let's begin from ADAS systems instead of autonomous driving, right? Because ADAS systems have evolved quite a bit from being passively a warning system. So think about forward collision warning, where a lamp would turn on and warn the driver, to automatic emergency braking, where the vehicle is taking control to brake, or to some extent in brake assist sort of features. So ADAS has evolved over time, and it's a natural shift from ADAS to autonomous driving, which is like L3, L4, and L5. These are different features, functionalities, and increased complexities, right? In order to achieve all of this, we see a lot of sensors like that are mounted on the vehicle, this being used. The most common ones that we see across the board is ultrasonic sensors, very widely used. They are primarily used for object detection, and they are really good for shorter distances, very close proximity ones. Then we have seen significant use of cameras and radars. Cameras have traditionally been used for helping the driver just to see or make them aware of their environment, right? But then in more advanced applications, they have been used for object detection, identification. So for example, a traffic sign identification, speed limit identification. Whereas radars have been used for applications where you need velocity, applications where you need an presence of an object detection, right? Now, with time, these things have evolved, and the newer, let's say in cameras, newer technologies that have come and improved. Now you can use a camera for even velocity or distance measurement. And the way you do it is like you take similar inputs from a camera, but then you process that data heavily to derive like different outputs, in this case velocity and distance. Similarly, the industry is heavily invested and looking into introduction of another sensor, LiDARs, because LiDARs offer like a three-dimensional, more holistic view of your environment, and they overcome some of the traditional limitations of radars and cameras. But again, none of these are like replacement of each other, and there is no industry consensus on what is the magic combination, what are the absolute sensors that you need to have. A lot of these things depend on your overall strategy for the functionalities, features, that you're trying to offer to your customers. And I think one key thing to talk about here is sensor fusion. And I think, David, would you explain sensor fusion here and probably touch upon the vehicle to infrastructure or vehicle to vehicle sort of aspects here?
Sure, thanks, Nikhil. I think one point I'd like to emphasize of what you were saying just now is that there's no perfect sensor suite for all applications. It really depends on the use case, and that's quite a key point. You talked about how some of the recent technology developments in terms of camera improvements, low light performance, lidars improving. We also see some of the frequency modulated lidars coming into the market or being developed, which are able to measure speed similar to a radar. And we also see some of the imaging radar with higher resolution. So there are technology developments happening across the board, across different sensors. Each sensor, as you said, has benefits, has advantages and disadvantages, and by combining them together, you end up with a quite a robust sensor suite, depending again on the applications. The sensor fusion typically happens at object level, where you combine different object data together to have a good understanding. But we started also to see how some players now started to do sensor fusion on the kind of raw data as well. You mentioned data connectivity. That's another dimension that adds an extra element of resilience into your perception suite. So through things like HD maps, which helps with your localization, with your path planning, and connectivity to the infrastructure, and that not just provides you that extra level of safety, but also cyber resilience. So some of the cybersecurity researchers recently demonstrated successfully how they can fool optical camera sensors by projecting what they call phantom objects, and that causes the system to fail effectively. So connectivity adds that extra level of resilience, certainly.
Yeah, and it really comes down to cost benefit, right? If a strategy is use limited sensors, you're essentially relying on more processing. The cost equation comes into play as the demands in the vehicle start increasing. The optimal strategy will kind of take shape, which brings us to our next discussion of what are the costs today and how will those evolve in time. Nikhil, do you want to quickly summarize what our findings were when we tore down a luxury vehicle that had partial autonomy, let's say level 3 autonomous system?
So, Anish, as you mentioned, when we tore down this L3 vehicle, what we found was like a lot of the costs in this particular vehicle was associated with the LiDAR that it was using for this specific L3 application. The reason it probably needed the LiDAR is the OE was trying to be from a safety and redundancy standpoint, it was trying to make sure like the feature functionality works properly. So if we try to think about the LiDAR and the AD computing features, the cost for those two things, they were like a very big, like almost 60% of the cost associated with the sensor suite. But then if we try to contrast this L3 application that we looked at versus some of our other projects where we have looked at cost breakdowns for various L2 ADAS features, what we see is in the ADAS features, the cost, like majority of the cost was tied to some computing as well as radars and cameras. But the more we move from ADAS towards L3, L4 and L5 sort of applications, we think the cost is going to be driven by LiDARs and the computing power that you need. With time though, the industry, like if I can contrast all of this to the beginning of the discussion where you talked about some OE players are actually looking at only camera options and they do not believe lidars are a necessity, right? uh, if I think about their equation in this, I think they will see a cost that will match to other OEs approaches, but they will see, instead of lidar cost, they will see increased processing costs. So their computing power that they need for deriving similar information from camera, you would see them having that sort of additional processing cost.
Yeah, and this is very interesting because LiDAR costs are really high right now, generally in the industry. There are some updates with LiDAR manufacturers about cost going below $1,000, and those will continue to go lower. But your point is excellent in terms of if you reduce sensors, you're spending cost in processing. David, do you want to quickly highlight how these costs might evolve in the future? We did some analysis for various volume levels of L3 and L4. Maybe quickly touch upon that.
Sure, thanks, Anish. I think cost is an interesting one. It's one of the arguments people said could be an obstacle for the adoption of automated vehicles. With technology development and with that being with the adoption of the technology in the market and the volume increasing, the economies of scales would kick in, and we can see a significant drop in the cost of the sensor suite across the range from different level 2 systems all the way to level 4 systems. Another element that comes into play is that the sensor suites, once we have some of the systems in the market, they will start to be streamlined and the cost will be engineered out of them. So there is both a time element and a volume element coming into play. But if we look just at the volume element, because with time there's a number of uncertainties when we expect to see certain systems being adopted in the marketplace. So if we just look at the volume argument, we expect, according to some analysis we've done, we expect the volume to decrease quite rapidly. So we looked at a hypothetical example where we have 10,000 vehicle units versus 1 million vehicle units. And we expect the cost to drop somewhere between a 40 and a 57% across different systems from level 2 to level 4.
Yeah, excellent discussion. We have a separate analysis on the projection of vehicle penetration for level 3 and level 4 that kind of drives some of our analysis on these cost estimates. We'll have a separate vlog on that, so stay tuned on that. Thanks, gentlemen, for the discussion today, and we'll see you for the next one.